Welcome back. I am Dominic Clevey of Central Washington University. Today we are going to be talking about properties of logarithms. We introduced logarithms on a previous class. We learned that they were important, we learned that they were fun, we learned that there's lots of things we like to do with them. We haven't learned much about how to use them, and crucially we haven't learned about this strange word. And so if you will permit me a moment of detour, let's talk about this word logarithm. What is a logarithm? Why do we call it what we do? Logarithm doesn't look like a word you might see in very many places. Where does it come from? A rhythm is perhaps an easier one. If you think hard, you'll think about this beginning. A rhythm is the same as the beginning of arithmetic. Arithmetic is the measurement of numbers. This comes from the Greek arithmos, which simply means a number. We're doing something with numbers, and the thing that we're doing is what? The log is a much harder word. Log, if you're interested, is the Greek logos, which means a lot of things. This word logos can mean study. Think biology, psychology, ecology, sociology, epistemology. All these ology words come from the logo part of logos. It can also mean word. It means word at the beginning of the Gospel of John. And he writes, in the beginning was the word. The word is logos in the original Greek. It's word almost in philosophy. If you've taken a philosophy class and have read Socrates and Plato, you know they're always looking for this thing called the logos. It has a lesser meaning of ratio, and perhaps that's what Napier intended when he named these things logarithms. It turns out we're not really sure. The study of number, the making numbers into words, the making numbers into ratios, something we're doing with this. But this is a logarithm, and it's worth, I believe, a minute of our time to see what's going on as we look at the word itself. More importantly for a math class, of course, is to see how to work with logarithms. We want to learn some properties today, and I want to remind you of the most important fact we learned in our previous lecture. Recall that if we write that y is the base b log of x, that this means precisely that b to the power of y is equal to x. If b to the y equals x, we'll say it backwards, then y is the base b log of x. Remember, we practiced this in many ways. This is the one big idea that gets us through. And in fact, based on this idea, the first four properties, if you think for a few seconds, should be obvious. In fact, I'm going to call these the easy properties of logarithms. The easy properties will tick off with our letters A, B, C, and D. The first is that whatever b is, the base b log of b always has the same value. It should be pretty easy to think what this is. B raised to some power has to be equal to itself, has to be equal to b. That number therefore must be 1. The base b log of b is always equal to 1. Similarly, what about the base b log of 1? 17 to the power of what equals 1? 17 to the 0 is 1, right? 34 to the 0 is 1. 8,000,006 to the power of 0 is 1. Anything to the power of 0 is 1. So b to the power of 0 is 1. If b to the power of 0 is 1, the log base b of 1 is 0. Remember, again, we're always using the ideas in this box. The base b log of b to the power of x. Well, if I have the base b log of b to the power of x, we ask ourselves what we had to raise b to the power of to get this whole expression, and the answer, of course, is x. I think you'll agree b to the x is the same as b to the x. And finally, the opposite of this, if I take this exact expression and write it in a different direction, I'll find that b to the power of the base b log of some number p is equal to p. This last equation, this property d, note, has one small caveat on it. Is it true for all values? Can I plug anything I want in here? No, but remember what we talked about before. The domain of the logarithm function is positive numbers. So this will hold only, in fact, if p is positive. These four properties, if you think about what logarithms mean, should be clear. And they're not clear as in the first time you hear them, they're obvious, but if you go home and spend 10 minutes puzzling hard, it should come to you. The next three are much less obvious. they're also much more important. So next to the easy properties, let's put the important properties, and I'm going to number these 1 through 3. Property 1 says that the base b log of p times q is always equal to the base b log of p plus the base b log of q. Don't write this down without thinking about it, or you'll miss what's going on. Take a logarithm of the product of two things. The logarithm of p times q is not log p times log q, but log p plus log q. Logs work very strangely when we start multiplying things. This, in fact, is a big part of their power. This is one of the reasons we love them so much. More on that in a bit, but watch out for the fact that this is not perhaps what you might think it should be. The second property is related. The base b log of p divided by q is simply the log of p minus the log of q. 1 and 2 should look very similar to you. We multiply or divide, we add or subtract to get the result. The third thing tells us what logs do to powers. If we take the logarithm of p to the power of n, the result is going to be exactly n times the log of p. We take the log of two things multiplied together, we add them. We take the log of something raised to a power of another one, we multiply. You can think of as n popping out front, you get n times log p. I don't want to spend time going over all of these, but I'd like to look at least at the first one of these. Can we see why this is true? Turns out it's not too hard to see why it's true, and if we do, it might remind us again how logarithms work. So let's see if we can prove. Prove exactly this. Let's see if we can prove that the base b log of pq is equal to the base b log of p plus the base b log of q. Prove is a scary word. Pardon me. Prove is a scary word, so if you don't like it, you can cross it out on your paper and write explain or figure out why or something like this. They're all perfectly fine words. We just wanted to see what's going on with this strange equation. Why when you multiply inside a log does it seem to match up with adding two logarithms together? And all we have to do this is have some new names. Let's take the base b log of p. We know this is something we're going to have to work with, and let's just name that x. It'll make our lives easier to have a name for it. Similarly, we're going to have to work with the base b log of q. Let's call that y. What happens now? Well, if I have this logarithmic equation, I can turn it easily into an exponential equation. If you practice a lot of times, let's practice it again. Take a moment now. Can you write this in exponential form? Time's up. You didn't get it fast enough. Practice more. We must learn these things well. If x is the base b log of p, then b to the x is equal to p. Similarly, b to the power of y is equal to q. Let's now take these two equations and multiply them together. Let's multiply the two left sides, multiply the two right sides, and look what happens. B to the x times b to the y is just p times q. We can simplify this. B to the x times b to the y. We're really good at simplifying this. We know this is the same as b to the x plus y. Are you paying careful attention? Did you notice that magic step? Did you notice something that was multiplied is now represented with a plus sign? That plus is going to be the magic secret that I'm pretty sure I bumped something, and I think we're back. You'll note we just changed multiplying to addition. B to the x plus y equals p times q. And how do we do this? What do we do next? Well, we know we need logarithms in the answer. Remember, this thing that we're trying to explain involves log base b. So let's take log base b of both sides. What's the base b log of b to the x plus y? Whatever it is, I know it must be equal to the base b log of the right side of the equation. I'm always going to do the same thing to both sides of the equation. What's the base b log of b to the x plus y? Remember, log base b and b to the power cancel each other out. This is one of our properties. This is property c on our previous page. This means x plus y is the base b log of pq. I also know what x and y are. We defined them earlier. Remember, x is the base b log of p, y is the base b log of q. If we put all of this together, we're left with the base b log of p plus the base b log of q is exactly what we hoped it would be, the base b log of pq. All this is to say that these properties of logs, these things that we wrote on the earlier screen, are not magic, are not things that some mathematician made up because he or she chose to do so. These are here because they must be true. Once we know what a logarithm is, once we know that a logarithm is simply another way of writing an exponential expression, then these things are forced upon us. They have to be true because this is what they mean. Alright, now that we have these properties, what can we do with them? Well, some of the most useful things that we can do involve combining terms and expanding terms. This will let us simplify a lot of equations later, so let's try combining. Combining and expanding. If you see a problem with this form, it might look like this. We'll call this example 1 for the day. We might say express as a single logarithm